Boosting trees. Y is again a function of x, and we want to estimate this function of x. That can be a regression or a classification problem. Why do we introduce boosting now? Boosting trees exactly in the framework of this course, of this chapter. There are some shortcomings that can be seen from trees. There are advantages, but there are also shortcomings. One of the shortcomings is to say, okay, bagging, for random forests, most of the time we have already talked about that. The trees may have similar structures. The same variables are often chosen. That makes that it's possible that we have misclassified data, for example, in a classification problem, which are repeated in several trees. The same data is misclassified in several trees because the variable which is able to correctly select this data is not chosen in the tree. All the variables are chosen before in the tree, and the variable which would enable us to correctly classify the data xi, the variable which could correctly classify this data, is not selected as a splitting variable in the trees. Therefore, it's possible that we have misclassification due to that. And therefore, there are maybe incorrect prediction in certain region of the covariates, since these corresponding covariates are not necessarily selected in the different trees. On the other side, trees have interesting properties in the sense that, indeed, we can see the other side of the shortcoming that we just have seen. The trees, whatever the method, but a method which is based on trees, bagging, random forest, they very quickly select very important variables. And they often select these variables. The consequence of that is that, in a way, if we are in a context where we have many covariates, these methodologies have the advantage to select, we could say, the most important ones. And when we have a very high dimensional problem, the problem is that we have too many covariates. The trees there have, I would say, a solution for that. They immediately select the most important ones, or we could think that these trees select the most important variables. It's very important for interpretation. It's very important in a high-dimensional problem to select the variables which are the most important ones. Therefore, what we would like to do is to keep this interesting property of selecting the good variables in trees. But we would like also, as I've just said, we would like also to improve the accuracy of these trees. The idea, and that will be the idea of boosting, the idea of boosting will be what? Will be to iteratively construct new classifiers that take into account the mistakes that have been done before. To better understand boosting, we stay in the context of classification. We will generalize it to regression after. But in the classification case, we are going to iteratively construct new classifiers such that they correct the misclassification step by step. Therefore, we could see the general idea of boosting with the AdaBoost, it's the name of the algorithm. With the AdaBoost algorithm, we see that we have a J of X, which is a final classifier. It is a weighted sum of classifiers denoted G index M of X. And we will have a weighted sum of these classifiers, and the sign of this weighted sum will give the final classifier. You will see the algorithm is going to be constructed in that direction. Therefore, what is the general algorithm of AdaBoost? Here we are not going to enter details. We are just going to try to understand basically what are the most important properties of this algorithm. Therefore, just at the end, we want to have this. This is the final classifier, the sign of the weighted sum of the classifiers obtained iteration after iteration. Initially, we are going to define weights that are equal for all the data, 1 divided by n. Next, we are going to see for each iteration, we are going to construct a new classifier G index M with the data, with the sample, and we are going to use the weights Wi. And on each iteration, Wi will give more important weight to the data which have been misclassified by the previous classifiers in the methodology. Next, we are going to compute a new error rate, Rm here, which is, the error rate of the new classifier Gm. Next, we are going to compute an influence, alpha m, of Gm. That means the weight that will be introduced in the weighted average of classifiers that have to be found at the end of the algorithm, and that we construct step by step. We construct this inference function based on the error, based on the error m that has been computed in the previous step. And at the end of the iteration, we update the weights Wi. That means that the data which have been misclassified by Gm, we are going to give them more weight for the next iterations. Therefore, this is the general idea. The general idea is to say, we are going to iteratively construct a linear combination of classifiers with coefficients here, alpha m, that have been computed. But, for now, it's not possible to fully understand that. We will see particular cases of this algorithm, and we will construct it. For example, in the next videos, we will construct it for trees. Just we can see what are the general formula. For example, Rm, you will see that it is a misclassification rate, which is for which each data has a weight Wi. This is the misclassification rate, but weighted misclassification rate. The alpha m is interesting because it's calculated as a function of the error m, and it's more important if the error of the classifier Gm is smaller. That means that for the better, if the better a classifier Gm, the higher will be alpha m in the final classifier. Therefore, it's an interesting property of this AdaBoost algorithm. It will give more weight to the best classifiers. And at the end, we will update the weights with this formula, and you see that in this case, this formula, it's not possible to fully understand how it's computed at this step, but what we can see is that, for misclassified data, this weight will increase. If xi is misclassified, the weight Wi will increase. Finally, what is the most important thing to understand now? To insert inside this algorithm, this is the function Gm. What are we going to choose for the function Gm? This is the question that for which we are going to bring solutions in the following videos.